Good afternoon, everybody. So let us start our lecture today. And today is October 14th, and we are in the second half of this semester and course. Okay, you see that I uploaded test 1, test 2. Okay, this will be available on October 21st from 2 to 3:10. Actually, it's an hour test. I give it 10 minutes extra. 10 minutes extra for everybody. But if you are entitled for double or extended time, this I will not count these 10 minutes. Okay, I will count an hour for this test. This will be mostly multiple choice test question, MCQ. Okay, and it is open book. But MCQ open book, that means you will not be able to get enough time to do Google search or read the book, and you need to study ahead like other tests. Okay,
So we're not doing it in person?
yeah, on D12 test will be on D12.
So we'll go here and take it on D12?
We will decide next lecture whatever we'll do. We will come either here or you can take from anywhere. I will think and decide. Okay, what do you think? What you wanna take from here or from home? Yeah, lockdown browser would work. Okay.
Well, if I take it here and the instructions are unclear, then at least I can ask you for clarification.
Yeah, let us think that. Okay, for now think about it is from home. Okay, you can take it from home or from anywhere. So if you take from home or from anywhere, you are responsible for internet connection. Your internet. If you get trouble about your internet connection, I am not responsible. Okay. I don't know. Even we hopefully we expect that if you come here, we have good internet connection, right? But if you face any issue, so immediately let me know. Okay. Okay. And then I uploaded updated syllabus, course syllabus. Syllabus, go to our syllabus version 4. Okay, so there's little bit change about put the test 2 schedule over here. So test 2. So far I put it in class. Okay, but I will decide next. We will decide next week, by next lecture. Okay, whether we will do in class or from home. Okay. Okay. So on D12 with lockdown browser, mainly one data structure, and it will cover red black tree, hash function, stack, QE, linked list, stack, QE, and AVL tree, red black tree. Okay, sorry, I wanted to add AVL tree here, I forgot. So AVL tree, red black tree, and hash tables and hash functions. Okay, that's it. And let us see. The part one slide, I added one slide. This is called hash table and hash function. So in our last lecture we are discussing hash table. Okay, hash table is a table that has key and value pairs, that contains key and value pairs, right? What are the keys? Are the actually entries, raw entries. Okay, and each key is processed with some function. Okay, to find the corresponding index value to put in a table. So So table is accessed, we know, using index, right? The table is by means a table that is an array type. Okay, so what is the speciality of hash table? That every element is accessed by its value, key value. Okay, not by its location. Unlike an array or linked list, tag, key, like other data structure, all elements are accessed by their locations. But in hash table, elements are accessed by their actual value. Sometimes actual value as is, or sometimes the value we get processed value. That means we process it some way. That in our last lecture we saw that we use some hash functions like modulus operation or some kind of operations, okay, to create a hash value. Okay, so sometime we expect that every key value, every key will be processed with a unique index key, but sometimes it does not happen. Sometimes two or more keys may have same index value, so that is called a collision, right? So whenever a collision is happened, so then we use some extra process to resolve the collision. How do we resolve the collision? The first element it comes, keep it on the position, and the remaining elements that collide, we get next available position in the hash table, okay, for them. That's it. So there are some some methods to resolve the collisions. For instance, one is called chaining, using a linked list for the elements that they share same index value. This is chaining. Okay, another thing is that we use some methods, those are called open addressing hash method, to locate the next available or previous available spaces for these entries. One of the simple one, we saw that in our last week, we do linear hashing, right? Linear hash function. So we're not going to come to that. The linear one. So there is a term, it's a terminal is called probing. Probe means whenever two or more elements, two or more keys share a same index. Okay, for the remaining keys we use probe values to find their locations. Okay, we will cover this. For instance, the simplest linear probing is that, for instance, in addition to a hash method, we use an extra variable. For instance, index variable, we can say I. It's simple I. For instance, if initially we put I equal to 0, and it is, what is the highest value of I? I can have its highest value m minus 1. What is the m? The modulus value. Okay, so I initially is 0. If that does not satisfy, that makes a collision. Okay, that's I0 means it is it's not getting exact position with probe 0. Then what do we do? In that case, we increase the value of I. to start from 0. Okay, so then start from 0, next one I plus 1, and then if we get in like, we will hopefully get a value for next available position. Okay, that is called linear probing. Linear probing, I increases linearly 1 2 3 4 5 6 7 on up to m minus 1, right? And then sometime it may not work, or it, since it will go growing be one by one, some can be upset. Oh, I need to look at fast. So in that case, there is another process, that quadratic probing. So the quadratic probing, that the I index I is a quadratic function. Okay, for instance here you see that so c1 and c2 any constant.
So basically,
You can take, usually you can take a linear like integer constant. Yes, what is your question?
This would be if the hash gets a collision, then you add a quadratic function.
Either quadratic or linear,
Okay.
or dual hashing, either these three ways in of this. Okay, but for instance, if there is no collision happens, then this I value or this I value or this the second one, this part will not be used, because for instance this there is no collision, then I equal to 0. Okay, in that case, if I equal to 0, that this part is not considered, right? In the case I equal to 0, so this part is not considered, this part is not considered. Okay, and in case of I equal to 0, this part is not considered. Okay, so I part will be used in case of collision. If collision does not happen, for some element or most of the keys, collision will not happen. So in that case, I equal to 0. For some elements, there will be collisions. So in that case, I will be used. Okay. So now let us see today. So these are straightforward. I added this in slide. So today, what I want to do, I want to give you let us practice this one. So everybody, please take your piece of paper and get the just problem. Okay, don't get the solution. Don't get this solution part. Okay, for now, get the just problem and let us try together and then see how it. So here we have we will be using double hashing. So these are key values. Okay, these are keys. We need to hash them. These are keys. We need to hash them, and we have. So here m equal to 11. Let us consider m equal to 11. Okay, this h function. Okay, we can say h1. h1 of x equal to x mod 11. X mod m. Okay, and h2 of x equal to x mod 7 plus 1. So modulus operator has higher priority. Okay, that means this part will be executed first. So here you can write this one. This is h1. This is h1. Okay, h1 equal to x mod 11 and a is 2 equal to x mod 7 plus 1. Okay, and these are x, set of x. Okay, these are x values are these one. Okay, probe means the number of try. That you get a location for a key in the hash table. First of all, let us do so. What will be the length of my hash table? What will be the length of my hash table? 11. Okay, 11. How it starts? So I have a hash table value 11. So then it starts from 0, 1, 2, 3, 4, 9, 6, 7, 8, 9, 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't need this part.
Sweet. Okay, so the
Yeah.
what is the M? What is the M?
M equal to 11 over there. MC module M, so x mod M.
Okay, so that's just the 5 for the first hash function. Okay. So we're just trying to insert those x values into the hash table. Okay. So first is 14. So 14 will go to 3.
Yeah.
Oh. So is M also the size of the hash table? Because there's like
Yes.
11 elements?
Yes.
Okay.
No, still working on it. That's
So since this is double.
Try it yourself. Don't look at my book. Don't look at my slide. Don't look at the slide. Okay. Try yourself. Slide is up. So don't.
So do we just have to fill the table, or do we have to worry about the probes too?
Huh?
Do we have to fill it? Do we have to worry about the probes too?
Yes.
Okay.
Find both probes and then fill out the table. And we will see there is a purpose of using probe. If it does not, probe is greater than 1.
Okay.
If probe is not 1, then we have to do something else.
And we have to go to the second hash?
We have to use both.
So like 25.
1 and 2.
Okay. So like the second hash will always place it in available.
Which hopefully it will get.
Okay.
So the third position will get 14.
The 31, 54, like you hash it once, you use it. And then like 16, you just hash it. Then you use 5, in the 5th position is filled, and you hash that, and get the 6th position, and that's already filled, so you do that.
Okay.
So then would you just hash it 2 again?
For 1 or 2, I don't know, maybe need multiple probes, more than 1 probes. So what are other else? Do the other stuffs, whatever they're easy. Do all of this for all entries.
Okay.
Do it each one.
So if you double hash something and there's still a collision.
So let us see that how many gates is positioned in the first occurrences with probe 1. Only 2, right? 25. Got it? So 25, the first one it got 3, right? 14 mod 11 equal to 3. Okay. And the first one always get probe 1. There is no chance that it will have probe 2.
Okay, I see what I'm doing wrong now.
The second one, 17 mod 11 equal to 6. It got position on 6. So 17 will go here. Okay. Third one, 25 mod 11 is 3. Okay. So it fails. So since it is same index that is already found or used, so then it will do the second hashing. So here the second hashing equal to 25 mod 7, this one first, then 4 plus 1 equal to 5. Okay, but let us go for other. See, then okay, so 37, this is 4, 3 times 3 times 11 equal to 33, right? 33 plus 4 equal to 37, and this is 1, and this is 5, and this is 4 already collide. So we need to probe 2 in the second. Let me take this.
already taken now?
Yeah. 16 modulus modulus.
5.
It's taken by the second half.
25
Over on the
modulus
right.
plus 1 is 5.
No, the regular one it will go for the, you see that now this is table, so they made this way, the table made this way. I cannot show whole thing, but you got right. First one you got 34, right?
Yeah.
34. Okay. 34. Oh, 34 is got 1. Okay. And then 10, 20, 25. Okay. Then how far you got? So then for 25 it position, this one got probe 2, right? So this one will get position, let me delete this term. Instead of this one, right? So this 5 you can do, so 3 plus 5 equal to 8. Okay, and this one probe 2, then 4 plus 6 equal to 10. Put this in 10 position. Okay. Now I deleted that one, right? Can I make it smaller and show it all together? You see on the screen, right? Okay. So problem are, I'm sorry, problem are with these two. Problem is with here with this one, that 3 is already found, right? So then use the second on, then we got 5, then input this 5 with it, then plus 5 equal to 8. Okay, then this one will get 1. Okay, and this one, 4 is occupied over here, so then 4 plus 6 equal to this 10 position. Okay, so then 10 is 26. Now I have a question, but let me ask you, do you have any question for up to this? Yes.
So you gotta add the probes 1 and 2 together for the 25 modulus?
Yes. So we are adding. Okay. So now, what happens? Does anyone? Let me ask you, if you have any question. I have a question definitely. So okay. So do you have any more question for this? This is the process. But what happens? For instance, here by the time I'm looking for position for 26. Okay. How about if someone has already position 10? What will happen? Understand my question? So for instance, for the second one, for instance, right, I'm resolving this one. Or even when I was making probe 2 for here, I got 8. Maybe someone 8 is already occupied over here. 8 is already occupied. Maybe there is a number, so 19 for instance. There was a number 19. 19 mod 11 equal to 8, right? So 8 is already, I saw that 8 is already occupied. Then I have to go to next one, next probe. Okay, so you see that the function we are using over here. Now let us look at the double hashing function. So we are hashing I equal to first one, okay, if initially I equal to 0, okay, and if I equal to 0 and this part, if using this part, right, the first hash function, if it works, then fine. If it does not work, then we use I, this part, right, initially I with 1.
So
We
if
start-
it fails 2 times, then we use
The first time I equal to 0. When I equal to 0, this only uses this part, right? So this part H1 does not work. This is why we are using H2 part. And with H2 part, whatever value we are using, I equal to 1, right?
So if that fails, then I will equal 2?
2, yes.
Okay.
If that fails, then I equal to 2. Okay? In that case, what will happen over here? I equal to 2, for instance, here that we will multiply this by 2, right? 5 times to 10, right? Then 10 plus whatever value is going to be, maybe 10 plus 3, 13. 13 and then make it module again, 11. Then it will get 2, right? Even if that does not work, make increase I again for 3. And hopefully at some point you will get a point. But a very rare case that we will say, you will see that someone unsuccessful. Some value is iteratively coming with the same all. I saw one example at least. The book has maybe one example or somewhere. I will add those on in this slide. So I have a few pages over here left. I will add those. So you understand the process?
Yeah.
Okay, process initially for all of these cases. I'm telling you what is this. I'm saying that here for all of these cases, here I equal to 0, and here I equal to 1. If the combination of these and this does not work, right? So our function was h1 x. Our hash function of x equal to h1x plus I into h2 of x. Okay, so this is initially I equal to 0, this part, and then whenever we are adding this part, I equal to 1, right? So this part is the combination of this part. This is why we found. So then maybe you can write another column. You can write another column over here, and then find, say, index 1, sorry, 3 6 3 6, and then 3 plus 5 8, and probes. So in the test or assignment, I will give you to ask. I will ask you to find both indexes and probes. Okay, and in case if there is something, there is a failure, unsuccessful key. In case it happens, rare cases that there will be an unsuccessful key. That means, for instance, you are increasing I 1 2 3. What is the maximum value of I can go? M minus 1.
M minus 1. Okay.
Right? I can go, for instance, here maximum till 10, right? And if you have to do 10 try and see that no, there is no empty space. There is an empty space, but we are not finding. Our hash functions is not finding the appropriate place. Then we say call that is unsuccessful. Okay. Okay. Now, for instance, why we are adding this for this one for 25, right? For 25, we are getting 3 plus 5, 3 plus 5, 11, right? 8, 3 plus 8. So it is getting 8, and then this one is getting 4 plus 6, 10. Why we are adding this? Why we are adding this and this? So now let us go to the previous page. By looking this our hash function, can you please tell us why we are adding this? Our formula is this. If we use subtraction sign over here, I could use, okay? We could use, instead of plus sign over here, you could use minus sign. You can use multiplication sign. Okay? You can use another function. Okay, that depends on you, up to you, okay? So that, for instance, in the test for some, a hash function will be given. Hash function will be given, okay? And then m may be given, or it will be said that, okay, take an m, arbitrary m, between this and this value, maybe 7 to 10, or 10 or 11. Take an hash value, m value, and then calculate the index table and probe values. Okay, let me see. I saw somewhere there was an unsuccessful. Let me find in the book. The book has somewhere. Okay, unless in the first source is unsuccessful, no element is the case. Unsuccessful. If I find an example. So double hashing. Okay, so in addition to this, so there is an example in the book. Please study this one, okay? These are the data set. 79, 69, 98, 72, 14, 15. These are the data set. Okay. Perfect hashing. So as I said, there are a lot of research going on hash. So you may find other hash methods. And we just cover these basics, this popular.
So
Okay.
are slide 31 and 32 like two different methods?
Slide 31 and 30.
Because like 31, 32. Because one uses like
31 is double hashing. Okay, and 32. It may have a different method. So any method you can use. hash method it can, so usually one thing that I told last time, right? M usually we put a prime number.
So like the slide 33 is using the method on 32, right? Because the hash is 2.
Same thing, this is the general formula, H1 k mod m equal to 11, right? So in the, so here H1 is here, H1 is k mod m, okay, and H2 is k mod is to choose to be slightly less than,
Because we're not actually adding the second hash to the first hash, like on the
here doesn't give this give H1 and H2 separately, so his hash function is a combination of H1 and H2.
Okay.
This is a combination. What you can do, for instance, sometime you can do the whole mod m. That depends on you. How do you write your hash function?
Because like when you did 2 probes, you did 25 mod 7 plus
So
1.
okay, so this is the hash function. No. This is the hash function, and the example hash function is different.
Okay.
This one is different. Whatever used is here. This one is H1. This one is used like this one. This one, Hx equal to H1x plus I into H2 x.
Okay.
And those example on the 30, this is whole mod m. That is another hash function. You can write your hash function as you like, okay? So it is not necessarily be the one. The general rule of thumb is that, for instance, we said that this m generally should be prime number. And the second m, this is also m dash, we call. M dash is another prime number less than this m. Here we say that m here, this is m here, m here equal to 11, right? And m dash over here. So that m dash equal to 7. Okay? The tradition is that you will use this prime number, okay, and this will be another prime number but less than m. So it says that some books say slightly less than. So this also can be like, this is prime number, right? 3 also prime number, 5 also prime number, 7 also prime number. So if m equal to this one, so which one we should consider for m2, m dash? So slightly less than is 7, right? You may consider 3 or 5, but so, but the norm is said that make it slightly less than or close to. Okay. And for instance, we have 11 is m, right? And we know that 13 is another prime number. So in that case, we should not be m dash. 13 cannot be m dash, right? Should not be 13. Should not be m dash. The rule is equal to m dash, which is slightly less than m. That's it for now for this chapter. Okay. Now this will be an assignment. This will be from some test question. Will be from this. Okay. From the in your test there will be some test questions. Yes. Take attendance. So again, so please be prepared, be ready for the test, upcoming test, and your test will be next week. During your class time, right? A week from now, right? Okay.